A spray nozzle lives or dies by one small opening. And pumping abrasive, corrosive slurry through a metal one rounds that opening off in weeks, until the fine mist it was tuned for collapses into a coarse, thirsty dribble. The gray swirl nozzles here are pressed from silicon carbide to hold that opening sharp, hard enough that the slurry scouring through barely touches it. Hardness is the heart of it. Silicon carbide sits near the top of the hardness scale, around 9.5, where diamond is 10. So the grit and slurry that grind a metal orifice wide slide past it almost without a mark. It is just as indifferent to chemistry. Acids, alkalis, and aggressive scrubbing liquors leave the surface unnetched across the full range. Heat holds no fear for it either. It carries warmth well and barely expands, so a sudden hit of hot gas or a temperature swing will not crack it. And the swirl chamber runs as one open, vaneless passage, so there is nothing inside for fibers or scale to snag on and clog. The flow stays clear where a fend or strained design would choke. The shape does something clever with the liquid. A tangential inlet spins the stream inside the chamber, throwing it out through the orifice as a thin, cone-shaped sheet that tears into a fine mist. No moving parts, just geometry. How much flows is set by the orifice and the pressure, and the link is not what intuition expects. Flow climbs only with the square root of pressure, so to roughly double the spray you must quadruple the push behind it. That is exactly why the orifice cannot be allowed to wear. Flow rises with the area of the opening, and the spray angle and droplet size ride on its clean edge. So a hole that erodes even slightly floods the flow and coarsens the mist. Keeping the opening hard and sharp keeps the whole spray on its design point, run after run. Specification starts at the bore and the thread. The orifice is sized to the flow and droplet target, the connection cut to a standard pipe thread, and the swirl geometry set for a chosen spray angle. A family that spans small single heads up to the large twin outlet vortex bodies that cover more area per fitting. From those basics, the rest is tailored. Orifice diameter, spray angle, single or twin outlet, thread type and size, and overall reach are matched to the flow, the pressure, and the header it threads into. Each one finished to a drawing rather than a fixed pattern. These nozzles earn their keep in wet scrubbing. The desulfurization towers where slurry is sprayed into rising flue gas to wash the sulfur out. Mounted in banks across the tower, the nozzles atomize limestone or lime slurry into a dense curtain of fine droplets, and that fine mist is what gives the gas the surface area to give up its sulfur. The abrasive slurry that would round out a metal orifice barely marks the silicon carbide one, so droplet size and coverage hold steady. The open swirl passage keeps solids from clogging it. And the corrosion-proof body ignores the acidic wash. The spray stays even across the bank, and the tower keeps scrubbing at its design efficiency.